All right, last little bit of significant figures. These are basic examples, but it goes through the process. If you have multiple units or you're doing math problems with multiple dimensions, uh, you're going to have values being multiplied, divided, added, or subtracted. And you have to keep track of the significant figures when you do that, because you want to know when you combine these measurements, well, how well is that measurement or combination of measurements going to hold up compared to what instrumentation that we had used. So if you follow these rules, your combined values will match up with how well the equipment was working. And basically, a lot of these rules assume that you're going to go with the weakest link, meaning what piece of equipment was not able to measure things to the same precision as the others. For instance, let's say for whatever reason I do two measurements, I'm going to multiply them together. Let's say I guess we're finding an area, right? We have 0.72 centimeters and 12 centimeters. And if we put those together in the calculator, we end up with 8.64. And that will be centimeters squared. Now, we still got to think about those units. Those units still must be used. Centimeters times centimeters is centimeters squared. But this is not reflective of the rules of significant figures. You have to realize that this particular measurement, for whatever reason, was measured with a ruler, could go to the hundredths place, apparently, so we had one place that was solid and one place that we had to guess, but this was two significant figures. This ruler, we could only go to the tenths place, and that was our guess, the tenths place. We said it landed exactly on 12, and we said 0.0 to keep that guessed placement there. To tell the reader, hey, it fell exactly on 12. But if I look at this, this is three significant figures. Now, to balance the two different rulers that we used and to keep the number in line, or the value, or the combined value in line with these measuring devices, we have to take our number that we multiply, and we have to apply the measurement that had the least amount of significant figures. So we ended up with a number when we multiplied 8.64, but we had one instrument that was measurement that was two significant figures. We had one instrument and measurement that was three significant figures. So when we apply them and combine them, we have to make our answer have two significant figures. Except our answer doesn't have two significant figures right now. It has three. So we have to take that value and we have to round it accordingly. We have to take this number and the 8 point. Now, we're going to go 8.6, but we have to look at this next placement. Is this 4 going to keep it a 6 or round it to a 7? Well, pretty obvious. If it's less than 5, it's going to keep it as 8.6. And so that would be our correct answer, using the part of the problem with the least amount of significant figures to dictate what our answer is going to be. Same thing with a division. If we take these two numbers, if we take 17.2 centimeters and divide it by 4.8 seconds, so apparently something's traveling, and we're going to look at its speed. So 17.2 divided by 4.8. And I get 3.583 repeating. Let me check that with my glasses, because I reached that age. So 3.583 repeating. 3.583 repeating. Now, we do still have to watch the units, centimeters per second, centimeters divided by seconds. And remember, you can multiply and divide units that are not alike. That is allowed. You just have to combine them correctly. So here we square things, divide things, multiply units, that's fine. Our significant figures, here we have, this has 3 sig figs, this has 2 sig figs, so our answer must be in 2 sig figs. Obviously it's not. And we have to round accordingly, so it's 3.5, no, can't be 3.5, it's going to be 3.6 centimeters per second. And that works. Now, sometimes, and I'll put a little side note over here, sometimes we'll get an answer of like 7.853. Just not these problems, but some other random answer we get in a calculator. And let's say that this particular answer had to be 2 significant figures for whatever reason, and you're asked to make it into 2 sig figs. Well, if you read our textbook, because this 8 is subjected to a 5, there are rules about, well, if it's a 5 before a number, sometimes you round it up and sometimes you don't. And I trust me, I understand the rationale behind those rules. Maybe I'm a bad teacher, but I'm going to say let's just ignore those rules. We're just going to use what we would learn in, basic math class. If it's a 5 before the number, I don't care if it's an odd or an even, if it's a 5 before the number, just round it up. That's acceptable. Look, not that I don't care about significant figures, I do. I understand their rationale and their reason, but when we take the AP exam, when they do count significant figures, you get a range of correct significant figures. If you do a math problem with a bunch of multiplication and a bunch of addition, and you have to keep track of all the significant figures as you go through, it can get tough. You get lost along the way. And trust me, later I'll tell you how to deal with multiple calculations and determining the amount of significant figures for the answer. But in this particular case, the odd-even rule with the 5 rounding, we got enough to do and worry about. Okay, so lastly, when you add or subtract numbers, I'm only going to do an addition. It's the same concept for subtraction. Really has nothing to do with the amount of significant figures in the parts of the problem at all. You're like, oh, that's 3 sig figs, that's 4 sig figs, that's 2 sig figs. My answer has to have 2 sig figs. No, not necessarily. Not with addition and subtraction. I will tell you, though, with addition and subtraction, that your units must match. You cannot add things or subtract things of different units. You cannot, you're not allowed. When you add or subtract, it's best to think of doing it like old school, grade school. You can take this and say, all right, well, look, I have 1.38, 7.580, and 4.6. And what I like to do is I like to add them up and I line all the decimals. So I line up all the decimals. Here we go. And then you can plug it into your calculator and then you can get the answer. Now, this is simple enough. I'm not going to plug it into my calculator. I'm just going to and this, of course, still would be in grams. Now, that's not correct with the appropriate significant figures. For addition and subtraction, you don't count the amount of sig figs and apply that to the answer. You use the value with the least amount of decimal places. This has 2 decimal places, 1.38. This has 3 decimal places, 7.580. This has 1 decimal place. So your answer is dictated by the value with the least amount of decimal places. That's 4.6. It's only got 1 decimal place. So $13.560 has to be looked at 13.5, but we still must ask ourselves, is the 5 going to be rounded or stay the same? Well, this 6 is going to make that 5 round up. And so we end up with 13.6 grams. That's our answer. in this particular case. Subtraction works the same way. Which value has the least amount of decimal spots, not significant figures. Okay, so hopefully this makes sense. If you have questions, obviously get in touch with me. And again, thank you.